So I had gotten a question regarding the homework assignment, and so I'm going to sort of answer that question. I'm going to bring up the particular question on the homework. Share my screen. Okay, so I had gotten a question on problem 3 on the homework. A school purchases a printer for $24,000. It has a 10-year life expectancy. Its value at that time is expected to be $2,000. Write a linear equation giving the value V of the equipment during the 10 years it will be in use. So the question I got was about the 24,000 and the 2,000, like how it could be worth both, or like, you know, what you do with those numbers. So when the printer is purchased, it's $24,000. So when we are writing equations, our x value, or input value, is always time. So I'm going to use t for time, and then the value of the equipment is going to be v. So you're telling us to use v, so that's going to be the output, the y value. So when you're purchasing the printer for $24,000 at purchase, it's been 0 years. So that's your time. At time 0, you just purchased it. No time has passed, so that's going to be 0 for t, and then the value of it is $24,000. Now it says that this printer has a 10-year life expectancy, and then its value at that time is $2,000. So what that means is that after 10 years, it is worth $2,000. So we are given two ordered pairs here. We have actually the y-intercept, or the v-intercept in this case, which is $24,000. And then we have a second point, 10, 2,000, where we then need to write this linear equation. So if we're writing a linear equation with the value v, this is going to be v equals mt plus b, because we don't know the slope, and then we've got the y-intercept. So we've actually been given the y-intercept, which is $24,000. And so then you would need to find the slope in order to get your full equation. Now I'm not going to do this exact same equation. I'm not going to do the same problem because I don't want to give you guys the answer, but I will work through a similar problem with different numbers. So I'm going to just open up, oh, that's not what I want to open. Here, okay. So I'm going to do something kind of similar. So we could do like a value of a car or something like that. So real life situation, I bought my car for, I think it was about $24,000. So at purchase, my car was about $24,000, which is actually the same amount as that the example we have on the homework. Now I just got notification by the Carfax that my car is now worth about 10,000 something. So Carfax says it's, we'll just say $10,000. We'll just round $10,000. So this, let's see, my car is 2016. So I actually, I bought it in 2016. So the 2016 is 17, 18, right? We'll say so at about 3 years. We'll just round it 3 down. After 3 years. So the Carfax says that it's $10,000. And so we want to write an equation for the depreciation of the car, presuming that it's going to depreciate by the same amount every year. Basically, you're assuming that it's a linear depreciation, so it's going to be decreasing by a constant amount. So we're given two ordered pairs. So at purchase, which is time 0, we have $24,000. And then 3 years later, the car is worth $10,000. So we want to do the equation of a line, and whenever you get an equation, you always have to find the slope. So the equation for slope, we always use m, so that is y2 minus y1 over x2 minus x1. And so we need to plug in our y values. And it doesn't matter what order you plug them in as long as you're consistent. I usually take go in order by the first point that I wrote, 0, 24,000, that would be x1, y1. 3, 10,000 would be x2, y2. So I'm going to be plugging in 10,000 for y2, subtracting 24,000. And then I have 3 minus 0. So 10,000 minus 24,000, that gives us a negative, not 12, negative 14,000. And then it's over 3. So I'm going to grab my calculator because I want to divide this out to figure out what the actual slope is. And we're going to round to 2 decimal places because our units for y are dollars, and dollars always has 2 decimal places. So this is going to give me a negative 466.67. So it's just a series of 6 repeating forever. So when you round that to 2 decimal places, it is 0.67. So before I write my equation, I'm going to just talk about what this means. So this is the slope, and the units on top of the slope are dollars. So this is in dollars, and then years. So this is telling us we decrease by this many dollars each year. So that's every year that I own the car, the value decreases by $4,666.67. That negative means that it is decreasing because we're always subtracting that much money. So that's our slope. That's how much the value of my car changes each year, which is by quite a bit. This is why they say that, the minute you drive that car off a lot. Now, cars in real life are not linear depreciation. They are more of an exponential decay kind of depreciation, where you lose a lot of value driving it off the lot, but then it's slower after that. But we haven't, we're just using a linear example here. So if I'm going to write my equation, so it's y equals mx plus b. We'll use v for the value. So v equals, m, and then t, we can use t for time, plus b. So b is the starting amount. That is your y-intercept, and that would be the purchase that you start with, which is $24,000. So I'm going to plug in my slope, which is negative 4,666.67 t plus 24,000. And so that would give us a linear equation that will model the value of the car. You just plug in how many years you've owned the car after that, and that would give you your value. So, like I said, this is we're making an assumption that it's decreasing by the same amount each year, which is not necessarily true in reality, but will work for our purposes. And one thing that we can do with this equation, figure out, well, when is the car going to be worthless? When is it going to be worth $0? So I'll do that in a different color. If it's going to be worth $0, then you plug 0 in for V, and you are solving for T to find out after how many years would this car be worth nothing, according to this equation. So to solve for T, it'd be easier if I add the 4,666.67 to both sides. So I'm going to add that value just so I don't have to deal with any negatives. So this gives me 4,666.67 T equals 24,000. So I'm solving for T, so I want to divide both sides by the value in front of t, the 4,666.67. So I'm going to put that in my calculator. And it comes out to, when you do that division, and you get a whole bunch of decimals. 5.14 and a whole bunch of other decimals. So that's the number of years after purchase. So that'd be about 5 years later, the car would be worth $0 according to this equation, which I actually have a 5-year loan. So that would mean presumably at the end of my loan, car isn't worth anything. Now we know that is not true because it's not actually a linear depreciation, but this is an example how linear depreciation works and how you can use the equation to figure out, when is it going to be worth some amount. So that was the question that I had gotten via email. It was about this particular, well, it was not this exact question, but it was about problem 3 with the depreciation. A lot of people also get confused on number 4. So for number 4, we've got a manufacturer of games notes that the variable cost for producing a game is 90 cents per unit and the fixed costs are $6,000. Each game sells for $1.65 if X is the number of games produced. You're going to first express the total cost as a function of the number of games produced. So usually people, they can do that. So it does say total cost, so that means you don't need the information about how much the game sells for, because that's not cost. So you're basically just using the 90 cents per unit and then the fixed cost of $6,000. For part B, it says to write the average cost per unit, where C over X. You're basically taking the total and then you're dividing it by the number of units. So when you're writing that as a function of X, you're going to have something, C of X, and then you're going to have your equation on the right where you only have X's in it. So that means you need to take whatever you have for part A and plug that in for C so that you have something that is just an equation that's in X. So those are the 2 questions that I usually get. And let's see, do you guys have any other questions, those that are online? Okay, well, I'm not seeing anything. Well, I was just going to do a quick lesson. I mean, my plan was to answer questions that anybody had, and actually I was planning on talking about linear equations because I knew these are the parts that people usually get stuck with. So I had planned in advance for covering the equation of a line, which I have done. So if you guys have other questions, you guys can email me. You can give me a call and I'd be happy to help you out. So, all right. Thank you for attending. Bye.